This is the next video on problems on kinematic of rigid body. In this video, we are going to look at the problems which has three links. Now, we are going to use instantaneous center method. Problem what we have taken is this, where there are three links AB, BC and CD. And what is given to us is angular velocity of AB is given as 3 radians per second anti-clockwise, and we are required to find angular velocity of link CD. Now, what you have to note, first task in these problems is to find instantaneous center of every link. For AB, it's obvious that it is A because it is in and it doesn't move, and that's why that's the point of zero velocity. Similarly, in case of CD, it is D because that's a point with zero velocity. Now for B and C, both are moving, so we need to work out the instantaneous center. Now look at link AB. First, because A is instantaneous center, velocity of B has to be perpendicular to AB in upward direction because AB is moving in anti-clockwise direction. Now look at link CD. D is instantaneous center, so C has to move up. So, and direction of C will be perpendicular to CD. So what we have managed with this is for the link BC, we now know velocity direction of 2 points B and C, and therefore by drawing perpendicular to these velocities, we can work out instantaneous center I for the link BC. Now please note here, at B, we have drawn velocity of B perpendicular to it, and then we have drawn perpendicular to this velocity. In other words, we have extended AB, and similarly, we have extended CD. So, to cut the long story short, if you want in three link problems to find the instantaneous center of the central link, all you do is extend the first and the third link. Wherever they meet, that's the instantaneous center for the central link BC. Now, for the newly formed triangle IBC, let's write sine rule. Before that, we have settled the geometry and we have written sine rule. See, sine rule IC, distance IC, upon opposite angle sine, sine 90 is 3.5, that is distance BC, upon sine 45 is equal to IB upon sine 45. Now this will enable us to work out IC and IB. Now we start with each link. Link AB. VB is equal to distance AB into omega AB because A is instantaneous center. AB distance is given 0.24, so we get value of VB. Then we look at link BC. For BC, because instantaneous center is at I, VB can also be written as IB into omega BC. VB we have worked out, IB is known from the sine rule, and therefore omega BC can be worked out. Further, IC is known from the sine rule, 0.35 by sine 45, and therefore we can work out VC as IC into omega BC. Omega BC we just worked out, IC we have worked out, so VC we can find out. And lastly, we go to link CD, wherein we write, first we work out distance CD from geometry, no big thing, 0.15 upon sine 45, and then we write VC is equal to distance CD into omega CD. Omega CD is only unknown, and that can be found, and that was what was asked. It's 4.8 radians per second. Now see, in this slide, some working is done till 4 decimal places, 5 decimal places. It's not required. 2 decimal places rounded off is good enough for the university examination. Next problem, one more problem on links. Let's do. Here is a 3-link problem. Links are AB, BC, CD. Now what is given is angular velocity of AB as 2 rpm. And we need to work out angular velocity of CD when AB makes an angle of 40 degree with horizontal. Okay, now Now, um, what we have to do is first we have to realize that for AB instantaneous center is A, for CD instantaneous center is D, and for BC instantaneous center can be obtained by extending the first and the last link, that is I. Settle the geometry for this newly formed triangle IBC, that is 30, 50, 100, and write the sine rule so that we are able to know distances IC and IB. And then go link by link. For link AB, VB will be distance AB into omega AB, 1.5 into 2, and that will be 3 meters per second. Then link BC, we can write VB as distance IB into omega BC. Distance IB can be taken as 1.96, which we can easily see from the sine rule, and therefore omega BC can be worked out 1.53 radians per second. Then IC, distance IC is 3.92 into sine 100 you get from sine rule, and therefore our VC, see we are looking at link BC, so we are using omega BC all the while, and it is IC into omega BC, that is 3.86 into 1.53. Omega BC is 1.53, so you get your VC, and finally you write the link CD, which says VC is equal to CD into omega CD. VC is worked out, CD is distance given, so only unknown is omega CD, which is 2.955 radians per second. Only one point here. Take this data, angular velocity of AB, not as 2 rpm, but take it as 2 radians per second, and you'll be okay. There is slight typo in that, but if you take AB as 2 radians per second, then all the answers which are worked out here are fine. Okay, so this is about 3 link. There's one more video coming up with some miscellaneous problems. Thank you.